All right, here are your notes for radical exponents. This is going to be our Unit 5, Lesson 6. Okay, so let's start with looking at our definition. The definition of rational exponent, basically we are going to be looking at when you have exponents where they're a fraction. Okay, I know it's a little hard with the type font, but basically what this is saying is if I have any radical as my exponent, any fraction as my exponent, the bottom will always be my root. So I can rewrite this as n to the x, the nth root of x to the m, or I can take, hey, I have the nth root all raised to the m, right? I can reverse those because remember these are inverse operations, so it doesn't matter which way you put it, and sometimes depending on the problem, you might have to switch it up a little bit, okay? So that is that. So let's go right into our first example. We just want to write the expression in exponential form, right? So we have no power. So my power here, remember, is just 1. So I can rewrite this as x to the 1/6. Okay, remember, whatever the root is, that becomes the bottom. And if I'm trying to do the 7th root of x to the 5th power, I can rewrite this as x to the 5/7. For these, the instructions aren't very clear, but basically we're taking our fraction as an exponent and rewriting it so it's in a radical form, okay? So the top number tells me, hey, I just have x to the 1st power, and I want this to be these to the 7th root. So I don't have to write the 1. So this is what you're going to end up looking, it's going to look like. I have x to the 3/2. Remember, I can rewrite this as x cubed. And remember, when it's 2, it's just a square root. You do not need to write the 2 here, right? That's like saying x to the 1st power. We don't need to write the 1. We don't need to write a 2 when we have a square root. All right, example 2. We're just basically simplifying these, okay? So we have 25 raised to the 3/2. That's another way of saying that. We could say is the square root of 25 all raised to the 3rd power. Well, the square root of 25, everyone knows what the square root of 25 is. That's just 5. And raise that to the 3rd power. That's like saying 5 times 5 times 5, which ends up being 125. Okay? That's our simplified answer there. Letter B. Okay, so now we have 16 to the 5th, all raised to the 1/2 power, right? I'm just going to rewrite this so it's one single exponent. Okay, so that 2 in the denominator tells me we're taking the square root, so I'm going to go ahead and rewrite it. So I'm just taking the square root first, and then raising that to the 5th power. Okay, well the square root of 16 is 4. We're going to have 4 to the 5th power. That's just going to be 4 times 4 times 4, and that is 4 to the 5th power is 1024. That's going to be A and B for example 2. So letter C and D, right, we're going to do these together. I'm just going to rewrite this so we have, it's going to be 9 to the 3/5. Okay, well we can't take the 5th root of 9, right, because it should be 3 times 3. That's really the only thing we can do there. I am going to expand. Okay, so for examples C and D, we have 9 to the 3rd, all raised to the 1/5. If I go ahead and do 9 to the 3/5, right? Well, we can't really take the 5th root. So what I'm going to do is I'm going to rewrite this 9. This is one way to do it. You can do it a myriad of different ways. We can do this. I can rewrite this so it's 3 squared all raised to the 3/5 power, which would turn into 3 to the 6/5, right? All right, well, this is saying here, this is just basically saying I have 3 times 3 times 3 times 3. I have 1, 2, 3, 4, 5, 6 3s to the 5th root, right? Well, I need to pull, this is just basically saying I have the 5th roots of 1, 2, 3, 4, 5, 6. So I'm trying to look for groups of 5. I can pull out 1, 2, 3, 4, 5, and I'll be left with 1 left over. So this is going to turn into 3 times the 5th root of 3. Okay. So down here, we have 10 to the 2/3, right? So this could be rewritten as, well, 10 squared is just 100. And we don't know, we can't really do anything with that 1/3. So sometimes they're just not going to simplify. So you can leave this as 10 to the 2/3. Or you can rewrite this as, let's do the cubed root of 100. Okay, so sometimes, like hopefully most of the time, they are going to reduce. But sometimes you're going to be left with a remain. You can pull some out. Sometimes you're not going to be able to pull anything out. And that is the notes for lesson 6.